Hello, today we're going to talk about combustion efficiency, how to take it, how to use your meter, and what to look for on a boiler. This is a KN6 boiler made by ATH, so it's 600,000 BTUs. We're using this boiler because, as you can see, everything's very easy to look at. Anything I'm going to be touching or adjusting today, you can see quite clearly. The meters here, I've got my gas meter here, and right up here I've got my combustion analyzer. They've both been on, looking at what's going on in the system. We want to have the combustion or the gas meter. Basically, we want to know that we have the correct amount of gas coming in at the right pressure to the system. For this boiler, they're looking for anywhere between 3 and 12 inches incoming gas pressure. If we look at our meter now, have to zero it out again. What we're seeing is we have 7.76 inches coming in. Like I said, I was looking for anywhere from 3 to 12, with 7 to 8 being ideal. So we're right in that ideal range. If that was out of range, or we had some way to adjust it, which we don't here, we are basically dealing with the city of Melrose Park, Illinois. This is the gas pressure they're giving us. This is what we have to use. If you had high gas pressure, you would be adjusting at your pressure regulator. Okay? But since we have what we want, we're going to start going in, looking and seeing what the boiler is doing now before we touch anything. Before you touch anything, you want to make sure you have the manual from the boiler itself. Okay? In the manual, you'll find all kinds of information. You'll find where the gas test port is. You'll find the high adjustment feature. You'll find the low adjustment feature. It's all listed in the manual. So please make sure you have a manual before you start doing a combustion test. Also in this boiler, it's hard to see, but we'll show you later, there's a tag in here from the manufacturer. Most high efficiency boilers are tested at the manufacturer to make sure the combustion is set correctly. That is going to vary from basically state to state. This boiler is purchased in Massachusetts or manufactured in Massachusetts. We're here in Chicago area. The gas is a little different. So that's why they want you to readjust and check your gas pressures and your gas combustion settings when you get it on site to a live application. Okay? So to turn this boiler on, basically turn the power switch on. There will be a screen here that normally lights up with everything on it. There are lights in this boiler. It's a feature the manufacturer provides. If you don't have some lights, make sure you get something in here. We all know boiler rooms are very well lit. I'm going to put it into what we call a calibration mode, which means I take over the control of the fan. By taking over the control of the fan, I can control the combustion up and down. This boiler happens to be 2 little switches here. As you see, the screen changed out now since I'm taking over. And now I'm in what it says, just like it says here, calibration mode. Okay, you're going to hear some noises and that kind of stuff. That's because this boiler isn't tuned in right now. All right, so we're going to let it settle out. Since it fired off, my combustion probe is right here. It was not in the actual boiler when I lit it off. You don't want your probe in the boiler during light off, because light off is it's an explosive environment. So you're going to have all kinds of gases. You could end up spiking your meter. So don't have your probe in the boiler, in your flue, when you're lighting the boiler off. Now I can put it in. Now with it in, you can see the CO2, which is the carbon dioxide. We're reading the percentage of it. Also O2, and this meter is showing me also the efficiency. Right now, since it was basically just lighting off, getting to an even point, everything was making a lot of noise. That's what you heard. You can see the meter jumping up and down right now. So right now we're in low fire, and our CO2 is reading 8.5. In the manual that this company provides, they tell you outside temperature is about 84, right in this range. plus or minus 0.2%. 8.6, I'm probably just a little bit low at this point. But as you can see, my efficiency technically is 99% efficient. If I want to go to high fire, I'm over here, this adjustment button. Now you're going to hear the boiler ramp up. This is a 5-to-1 boiler, which means it ramps up in 20% stages. So I'm going to fire for 80% technically of the boiler. What you're going to see over here, my efficiency is going to drop because I am firing a much bigger fire in the same amount of water. So basically it's going to drop down, and my CO2 will also drop down. Right now it's going to bounce around a little bit. When you're doing combustion testing, this is not a 5 seconds, 10 seconds, 5 seconds, 10 seconds. This is, you're going to have to wait a minute or two every time. Sometimes 3 minutes. It all depends on the size of the system and the responsiveness of the boiler. The bigger the boiler gets, the slower it is going to be to respond. So be patient. As you can see, the temperature is going up because we're still moving the same amount of water, so we can't take as much heat out, so the flue temperature goes up. That means our efficiency, our calculated efficiency, is going down. All right? I'm not really worried about these numbers right now, the CO2s, but I just want to see where we're at. Okay, so we seem to be about 9% there. My gas on high efficiency has dropped about 5.9. That means it went from about a 7 to about a 6. That's well within the range of this manufacturer. Like I said, this boiler can fire down to 3 inches of water column. Again, I have no way of controlling that because I am limited to what the city gives me on this job. All right? So now our high efficiency seems pretty well close to being in range. High efficiency should be 9.2. I'm sitting at 9.1. And my efficiency when I first started that was at almost 97%, is down to 86. The longer I run this, probably the more it will drop down. But let's get to actually playing with the burner itself now in the gas valve. I'm going to force it all the way down to low so the set point doesn't take over. And we're going to look at how to adjust it. This boiler, I can go either way on it as far as high fire or low fire first. They're not that far out of range. Most of the time when you get a new boiler, you're not going to find it dramatically out of range unless somebody's just played with it. Okay? So basically now we're going to see low fire is coming down. Our efficiency should start going up. And we're going to try to get our CO2 at about 8.5, 8.4, 8.5 on this thing. As you can hear right now, we're picking up our harmonic noise. We're going to try to, we want to definitely get rid of that before we leave and make sure it's still within the ranges that's here. So basically on this Dunes gas valve, our low efficiency or our low combustion adjustment is down here. A lot of times they're called offsets. With this valve, it actually has a little gate on it. So if people don't know where it's at, they don't find it. Since you've watched this video, you're going to know where it's at. So this happens to be a 2mm Allen. Going to put that in there and try to get rid of that harmonic. I'm going to go up half a turn and see what happens. Right now it sounded like it got a lot noisier. My temperature is pretty much stabilized. My CO2 is going up a little bit. I said it should be in the 8.4, 8.5 range. It's actually going up. So that means I want to go the opposite way. I've given it about 15, 20 seconds. So I'm going to take my half turn back. And I'm going to go half turn off there. As you can hear, it quieted up. What's happened to my CO2? It dropped down a little bit. My efficiency's holding. Drop down another tenth. Again, do not make an adjustment and immediately go somewhere else. Let it settle down. Now we're down to 8.9. And you hear no noise at all. Okay? Not bad. But really I want to get down to this 8.5. I think I'm going to take maybe another half a turn. I'm going to repeat this probably a dozen times. Don't make big adjustments. A lot of guys will sit there and they'll spin this a whole turn. If you do that, you have no idea where you're at. Like, that's a lot of turn in here, okay? So I'm going to take just another half turn here. That's a quarter turn. Let's just take it at a quarter turn. See what happens. My efficiency went up a hair. My CO2 basically didn't even move. Is that okay? Yeah, it's okay. We don't want to jump around here. Okay, that quarter turn did not a lot. Let's just push it down. That's a full half turn again. That was a half turn there. So efficiency creeped up a little bit. My CO2 is still about the same. Technically, this boiler is burning 125,000 BTUs right now. So that little change is going to take a while to siphon its way through the system. There we go right now. We dropped down 8.7. We're getting very close with the difference there of 0.2 to where we want to be. Yeah, as you can see, our efficiency is 90.1. So let's just say, let's take that as 8.8, which is a good number. 91.4, a good number on efficiency. 91.5. And let's lock that in. And let's go to our high. Let's see what it does. Now I didn't take that out because I'm not going to adjust that anymore on the low side. On the high, this gas valve, there's a screw right here. And this screw, very small, their blades go up and down. It's made of aluminum, so my steel screwdriver is not going to stick in it. But let's watch what happens now. So on our high fire, we should be going up to about 9.2, 9.3 area, plus or minus a 0.2%. As you can see, our efficiency is going down. Our CO2 is going up a little bit. It's actually almost right in the range that it should be. 9.2, I'm looking at 9.2, 9.3. I'm right here. Okay? As you can see, efficiency goes down, stack temperature goes up, efficiency goes down. We are not dumping as much heat into our system. More of it's going out the stack right now because we have a much bigger burn, more BTUs we're throwing into the system. Right now with this, I wouldn't do anything to it, but just to show you on the video what happens. If I start increasing the gas, but you jumped all the way from 9.2 to 9.8 with half a turn. Again, little turns are much better with combustion efficiency. So let's take that half turn back to try to get something out of here. All these numbers I'm coming up with, other than what's in here, is just learning that piece of equipment. Every boiler is going to be a little bit different. So basically, you get the manual for that boiler. If you don't have it, go on the internet, get it for that year or whatever, because these numbers do change. I've been working with this boiler for about 10 years now, and the numbers have actually been dropping. So they've been improving the efficiency of the heat exchanger and other stuff you have no control over. So they do change over time. See if things change, but what I would do at this point, since we're satisfied with this number, lock that in. I'm going to shut off the calibration mode, which is down here. I'm just reviewing my gas. It only dropped to 6.2 on high fire. If you have multiple boilers in the system, it's very important that you have your gas meter on one of them, or a common point is the best, where you can turn on all three boilers and make sure you don't drop below your minimum. I turned it off. I'm going to go pull my meter out because I want to start the boiler up. again, just like it would be a natural fire. So I don't want my meter in there. I'm going to let the boilers basically fire itself. Calibration mode is off. The boiler now is going to come back up to a normal cycle at the set point and get to that point and do itself. What I'm looking for here right now, I don't want to hear a bang. I don't want to hear a boom. Somebody jumps off their chair. I don't want to hear this thing. Right now you're going to probably pick it up because the whole front cover is off. All this is off. There's also a shroud that goes down is off. So you might hear a little bit of noise on the video. That's typical pre-purge. Every high efficiency boiler has a pre-purge. What that does is make sure that whole combustion chamber has no gas in it, just air. That was the pilot valve opening. So now right now my pilot is going for ignition. It's in local set point is what it's called. It's lit. This boiler lights off at 40%. So that means it lights off at about 250,000 BTUs. Why does it do that? Because you don't fire it off at low fire. It's a very unstable flame. Fire it off in the middle. Picking up a little bit of noise. Let's see what happens if it goes away. Yep, it went away. So that's the first official light off of that boiler. Made a little bit of noise. If I want, I could try it again. The gas valve will settle in a little bit. Okay, so you can fire it a few times. I normally like to fire a boiler, and this manufacturer likes us to fire it 10 to 15 times after initial combustion settings, just to make sure it fires off quietly and everything else. Hopefully today we've shown you some pieces of the combustion process, how to use your combustion analyzer, and what it really means. If you follow these steps and follow the manufacturer instructions, you'll have your boiler run at peak efficiency, saving you energy in the long run.